Hey everybody, welcome back to my channel. In this tutorial, I'm going to demonstrate how to calculate some descriptive statistics, particularly related to measures of dispersion. So, what are the measures of dispersion? As you might have seen in the descript intro statistics book, that measures of dispersion actually account for how far your data points are from the mean, basically, right? So how spread your data sets are, how spread the values of a variable are, so from the mean, right? So that's what we do here. So some of the common measures of dispersions are standard deviation, variance, range, interquartile range. So these four that I'm going to demonstrate now with the dataset that I have already loaded here. So I have also written my Stata codes here, which is very simple. Let's go to the codes or do file. And here I'm using a variable called BP systole, which is systolic blood pressure. And summarize or sum command is pretty common that you should be familiar by now. And then with an option called detail. So I'm going to select this and run the selected command and see this descriptive statistics with the details. So some of the descriptive statistics I'm looking for is standard deviation and variance, right? So what is the standard deviation and variance? So let's talk about it. Standard deviation basically measures how far your distribution, your values from the means are. But variance is a kind of similar thing. However, there's kind of difference between the two. So it's variance basically, accounts for how far each of the value in your variable stand from the mean. It is below the mean, also above the mean, and then add them together, average them, and square them. The reason behind the squaring all the data points, all the deviation, is because you get rid of the negative sign so that you can average them, and you get an average squared value for this measure. However, variance value is not in the original unit in which the variable was measured. However, standard deviation does exactly the same thing, which is the square root of the variance, right? So that's why we use the standard deviation to add or subtract from the mean. For example, if here we can see the standard deviation is 23. So if you add 23 with 130, which is mean, and then also subtract 23 from 130, then your values lie between these two range, right? Like majority of most of your values lie within that range, because this 23 is comparable with this original unit. So one means the same thing here, right? So you can use mean plus minus 23. So that's how you measure the spread of your data, right? Which variance can't do that because it's not in the original unit. I hope you get a sense of this, but I'm not interested in talking more about these technical details. So what I am going to show you is that how to produce in its data and what is the application of this statistics. So by this statistics, you know how spread your data are, right? So that's what the main thing. So when you look at standard deviation next time, so you can immediately get the idea that it is this 23 is just plus minus the mean, so that you can get an understanding where your values are from the mean, from the average, right? Okay. So the application and how to produce it in Stata. Now, I have more Stata codes. So far we have already produced the standard deviation and variance, but now it's already produced. So we can display that again with this command, display, and this is just the name, and that is between these two quotation mark, and this is saying that R means a stored result. This is result, right? Already we have produced this. Now we have this stored result. Stored result of what? Stored result of SD, which is standard deviation. So if you select this and run the selection, and it gives you the display of what is your standard deviation, which is already there, right? And then similarly, you can do the same thing for variance. So you are calculating the variance, right? The stored standard deviation and square it. Okay, so and we know the formula, right? So if you square the standard deviation, that is your variance. Okay, so you click the selection and then you produce the standard. You produce this variance. It's the same thing here. So same thing here, right? Okay, and then we have range. So first you produce the range, calculate the range. Local range equal R, which is the stored result, maximum, and then this is 2. So this sign, and then R, stored result of minimum. Okay. So and then the next command, also select the next command, which is going to display it in the output window. So run the selection and see the results. So the maximum minus minimum is 235. This is how we calculate the range, right? Minimum maximum. So what is the difference between the two is our range. Okay. And then finally, interquartile range. So we're going to create the interquartile range. So do you know what that means? That means you subtract 25th percentile from 75th percentile, so that you know the middle 50% of your data. Okay. So what is the middle 50% of your data? That's what interquartile range does. So first produce it here. And then display it. So local IQR equals stored result of 75 minus, so which is 70. P is percentile 75th percentile basically, and minus stored result percentile 25th. So if you subtract that, you get the IQR, which is the middle 50%, and then the display as we have seen before, and click the selection and see 28 is the interquartile range. That is the middle 50% from 25th to 75th. So if you subtract the value of the 75th percentile, 25th percentile from 75th percentile, that's how we get IQR or interquartile range. So these are some measures of dispersions that I have calculated. I hope these things make it easy for you to produce this results and understand it from the layperson perspective. Thanks for watching. If you like my videos, please subscribe my channel and like, comment, and share. And if you want any specific video to be produced, let me know. I will create a video for you. Thanks again.